Good morning to all of you. This is Muva Prasad signing into DCEB Suryapeta online live streaming classes. Now we are in the probability topic. Now we are in the probability topic. Already Purushottam sir has given the basical concepts, maximum basical concepts based on probability, which are definition of probability. What is the difference between a theoretical probability and experimental probability, the terminology which we are using in probability, and the main basic fundamental formula how to find the probability, which is already explained to you, and the remaining a little bit of source is required to complete this chapter, that is the elements which are on playing cards and dice and etc everything that will be introduced by our Purushottam sir. So today, after giving that information to you, total basic concepts, then he will go through the exercise questions. So once you are familiar with these basic concepts, then the exercise questions will be the very easy for you. That is the main intention of our Purushottam sir, to introduce the basic concepts more priority than the exercise questions. Once you got the basic concept, then automatically while you are reading the question itself only, then you will get an idea how to solve the question by analyzing your basic concepts to convert that one into the fundamental formula type. What are the required data, you will get an idea if you are familiar with your basic concepts. Purushottam sir, we are very pleasure to have your lecture. Please go through the class.
Thank you. Thank you, sir. Good morning to children. So, okay, children, today we are going to discuss about second day class on probability, and I think you may gather some information about probability on a certain topic, and also we discussed the types of probabilities which are experimental or empirical probability, and another one is theoretical or classical probability, and also we discussed some terminology on probability, and what is trial and what are outcomes. So I think you have gained some knowledge on it. Now we are going to second day on probability, second class children. See children, okay. Now today we are going to discuss on probability, fully information about probability. Now we discuss what is classical definition of probability. See children, here yesterday I told the definition. Once again I will repeat it. Classical definition of probability. Okay, give children what is classical definition of probability. Yes, probability of an event P of E is equal number of favorable outcomes by total number of outcomes. Already we discussed children. This is a very important formula. The formula use total topics, total exercise. So this is very important formula. Children, note down this formula. Probability of an event. P of an event. E means here event. P of E is equal number of favorable outcomes by total number of possible outcomes. This is the classical definition. Please note down this formula, children. And now I will try to give more information about the history of probability, children. See children, here probability theory had its origin in the 16th century when Italian physician and mathematician J. Cardan wrote the first book on the Subject, the book on the games of chance. Children, the first in a 16th century mathematician and physician J. Gordon wrote a book. The book name, the book on the games of chance. First, he will try to give the probability. What is probability and some terminology used on that book. The book on games of chance. The first 16th century Italian J. Gordon wrote this book, and James Bernoulli and A.D. Movier and Pierre Simon Laplace are among those who made significant contribution to this field. Children, there are so many mathematicians, so many scientists are contribute their contribution. Now we learn their contribution with detail. So here Pierre Simon Laplace, also one of the mathematicians, James Bernoulli and J. Gordon, these mathematicians are contribute these contributions. And in recent years, probability has been used extensively in many areas such as biology, economics, genetics, physics, sociology. See children, here probability, nowadays probability has been used in so many areas like biology and economics and also genetics, physics and sociology. So probability is very, very important topic in our daily life, children. So we have must learn about probability. See children, so this is very, very important in our daily life also. It is useful in biology also, economics, so many areas. And children, here already we learnt the definition of probability was given by Pierre Simon Laplace in 1795. Children, the common sense reduced into calculation, already the definition. This is a very useful and important definition was given by Pierre Simon Laplace. Children, in 1795, Pierre Simon Laplace, one of the mathematician, given by the definition was given by him. And children, now we will discuss if a coin is tossed, we get a head or tail, but not both. See children, if we take a coin and toss it, it may be head or tail, but not both. Only it turned up only head or tail. Similarly, see children, if we select a student of a high school, that he or she may belong to one of either 6th class, 7th class, 8th class, 9th class or 10th classes. See children, if we select a student, in a high school student, in high school, if we select a student, he belongs only one of the class, whether it is 6th class, he belongs to 6th class, or he belongs to 7th or 8th or 9th or 10th. But he belongs to both, but not belongs to both classes. Okay, so here, but not to any two or more classes. In the same way, in both these examples, occurrence of an event prevents the occurrence of other events. See children, one student belongs to 6th class, he does not belong to 7th class. So occurrence of event prevents the occurrence of the other events. So such type of events are called mutually exclusive events. Mutually exclusive events. So I will give some more information on this mutually exclusive events. See children, here, two or more events of an experiment. In an experiment, two or more events of an experiment where occurrence of an event, occurrences of all other events are called mutually exclusive events. Children, already we discussed If we toss a coin, it belongs to only head or it is tail, but not both. In the same way, so one event occurrences of other event, one event occurrence of other event, so that these are mutually exclusive events, mutually exclusive events. So children, here once again I will try to give how to finding probability. How to finding probability. See children, here how do we find the probability of events that are equally likely? So equally likely probability, how we can find the probability? We consider the tossing of a coin as an event associated with experiments where the equally likely assumption holds. In order to proceed, we recall there are two possible outcomes of each time. So children, if we toss a coin, the possible outcomes are two. So this set of outcomes is called the sample place, sample space. Children, here when we toss a coin, only two outcomes are there. What are they? Yes. What are they? Head or tail. So this set of outcomes, head, tail, the set of outcomes are called sample space. Children, what here? Sample space. We can say that sample space of one task is H comma T. Have understood children? The sample, the all possible outcomes are called, the set of all possible outcomes are called sample space. Children, here sample space is a one important term called sample space. So here if we toss a coin one time, the sample space is HT. Further experiment of drawing out of a ball from a bag containing red, blue, yellow, and white ball. The sample spaces are. So here a bag is there. A bag is there. In the bag, a red, blue, yellow, and white balls are there. A bag contains four balls. A bag contains four bags. The colors are red, blue, yellow, and white balls. So that here the sample space is, listen children, listen carefully, the sample space here, red or set up, or red. Here R means red, B blue, Y yellow, here white. So here the sample space is nothing but total outcomes. We may take total outcomes. So and we see another example. What is the sample space when the dice is thrown? Think children, what is the sample space when we roll the dice? So we see children, here once again sample space. See children, sample space. Okay, here the sample space definition is, it is the set of all possible outcomes of random experiment. What is sample space children? It is a set of all possible outcomes. So when we toss a coin, the possible outcomes are H comma T. In previous example, red, white, yellow, in the set, so those are total possible outcomes. And when we toss a coin, see here, when we toss a coin, or when in rolling an unbiased dice, we throw a dice or unbiased, when rolling unbiased dice, sample space. What here? Sample space. S is equal 1, 2, 3, 4, 5, 6. Think children, why? Sample space here 6. Why? Because total possible. If we roll the die. If we roll the die, total possible outcomes. If we roll the die on the top, it may be 1 or 2 or 3, 4, 5 or 6. So these total possible outcomes are we may take as a sample space. Sample space. This is about enrolling an unbiased dice. Sample space this. So number of outcomes 6. Here we estimate the sample space here using this sample space we find out easily number of outcomes. Number of possible outcomes. How many? 1, 2, 3, 4, 5, 6. So this is the outcomes. Sample space is set and number of outcomes is here 6. And we see another one in tossing 2 coins. When we toss 2 coins, sample space. See children here, when we in tossing 2 coins, sample space, yes, it may be H. First coin H, second coin H. Or first coin head, second coin tail. Or first coin tail, second coin head. And both are tails. So the sample space is when we toss 2 coins. When we toss 2 coins. And when we toss only 1 coin, only sample space is H comma T. Here, the number of possible outcomes, how many here? Number of possible outcomes, 1, 2, 3, 4. Have you understood? Number of possible outcomes, 1, 2, 3, 4. Here, number of possible outcomes, 1, 2, 3, 4, 5, 6. So, sample space is easy to find out the number of possible outcomes. So, this is a sample space. Set. Sample space is nothing but set of. Write down children this. It is the set of all possible outcomes of random experiment. Random experiment. So this is about a sample space. Write down. Please write down the definition of sample space, children. And also, when we rolling a die, the sample space is like this. If we toss 2 coins, if we tossing 2 coins, the sample space is like why we use sample space? We use sample space to find out number of possible outcomes easily. Number of possible outcomes easily. Next, children. So here, one example. We will try to learn about one example. So children, listen carefully here. Find the probability of getting a head when a coin is tossed once. Also find the probability of getting a tail. See children, here one example is there. So I read it once again. Find the probability of getting a head. Getting a head when a coin is tossed once. When we toss only here, how many times tossed here? Only once. Also find the probability of getting a tail. Okay, see children, now we will try to solve the problem. See children, here. So solution here. In the experiment of tossing a coin once, the number of possible outcomes is what children? Yes, 2. What are they? Whether it is head and tail. The possible outcomes are only 2. When we toss a coin, the outcomes are head or tail. So here 2 possible outcomes. How many possible outcomes? 2 possible outcomes. Let E be the event getting a head. Here already the first one. Getting head. E be the event getting head. The number of outcomes favorable to E. So we go through the formula. Here the number of outcomes favorable to E is 1. Getting of head when we toss a coin once, whether it may be head or tail. That possible here, the possible is only one. To getting head only. To getting head is one. So therefore, P of E, probability of an event. Probability of event. Event means here what? Event means here getting head. E means here getting head. Probability of getting head is equal. So we recall the formula. What is it? Number of outcomes are favorable to E by number of all possible outcomes. So the formula is favorable outcomes divided by all possible outcomes. Already we find favorable outcomes, how many? Only one. And total possible outcomes, how many here? Two. So 1 by 2. Here the probability of getting ahead is what here? 1 by 2. 1 by 2 means 50%, 1 by 2. Similarly, here if F is the event getting a tail, second sum. Similarly, if F is getting a tail, so here P of F, that means here E means getting head, F means getting tail, that's all. F means getting tail. So P of getting tail, probability of getting tail is equal to number of outcomes of favorable to F by number of all possible outcomes. See children, number of, here what is the formula? The classical formula is what? Number of outcomes favorable to E by number of all possible outcomes. So here getting a tail possible, how many? Only one. Getting a tail favorable, one. So already number of possible outcomes is there, 2. So here 1 by 2. So if we toss a coin once, getting a head is 1 by 2. Getting a tail, and the probability of head is 1 by 2. Probability of getting tail is 1 by 2. So this is a 50-50 chance, equally likely. Have understood children? So here this is getting, probability of getting head is 1 by 2, and also probability of getting tail. Here E means getting head, F means getting tail, 1 by 2. Okay children, next. See children, another example is there. Children, another example. Listen carefully children and see children here. Suppose we throw a die once. Already we discussed yesterday what is a die. Die is nothing but a cube with 6 surfaces. Each surface contain numbers or dots like this. So suppose we throw a die once. What is the probability of getting a number greater than 4? Listen carefully children. Here the probability is greater than 4. Getting a number greater than 4. Second one is, what is the probability of getting a number less than or equal to 4? Okay. So here 2 problems in this example. 2 sums are there. Number one is getting a number greater than 4 and getting a number less than or equal to 4. Now here solution. In rolling an unbiased dice, if you roll the die, sample space are just with length about it. Sample space. What is the sample space here? S is equal. Set 1, 2, 3, 4, 5, 6. Here number of outcomes. Just now I would explain about it. Number of outcomes. How many here? 6. Sample space is this. This is sample space. And number of outcomes. How many number of outcomes are here? 6. So favorable outcomes for number greater than 4. Here what we want here? The question is the probability of getting a number greater than 4. Greater than 4. So the favorable outcomes are, so here 4, 5 is greater than 4 and 6 is also greater than 4. But 1 is less than 4, 2 is also less than 3, also less than 4. So here now what favorable, how many here? Favorable outcomes, how many here? How many? 5 and 6, only 2. Why? Because greater than 4 only. Greater than 4. The number of favorable outcomes, how many? 5 and 6 only. So number of favorable outcomes are sample space, number of total outcomes. Sample space, favorable outcomes. Why? Because the formula is there. Formula is probability of event is equal to favorable outcomes by total possible outcomes. Total all possible outcomes. That's why we find total number of outcomes, favorable outcomes. That's why. Here, number of favorable outcomes of number of E is equal to 2. E here, number of favorable outcomes here, 2. So the probability. So here the probability is, here the what is probability here? The probability of getting a number greater than 4. The probability is getting a number greater than 4 is equal to, so here number of favorable outcomes to E. Here number of favorable outcomes to E divided by total number of all possible outcomes. Already we find favorable outcomes here 2. Here 2. And total possible outcomes here 6. So 2 by 6. So here 2 ones are 2 3s are. Your probability is 1 by 3. Probability is 1 by. What's the probability? This one number of what's the probability? The getting a number greater than 4 is probability is 1 by 3. Remember it, 1 by 3. Next second one. Let F be the event. Let F be the event getting a number less than or equal to 4. Second one. Here, let F be the event getting a number less than or equal to 4. Here, total sample space. Total sample space. Here, sample space is what? 1, 2, 3, 4, 5, 6. This is a must sample space. Here, now we find favorable outcomes. So your number of outcomes is 6. This is not changed. This is 6. In a previous sum also. So the previous sum also is 6. So here what we find here? Favorable outcomes. Favorable outcomes. That means here getting a number less than or equal to 4. Getting a number less than or equal to 4. So here total number is less than or equal also. Less than or equal to. Already here 1 is less than 4 and 2 is also less than and 3 is also less than. 4 is equal to 4. That's why you may take only these number 4. Favorable outcomes are 1, 2, 3, 4. Have you understood, children? What? Getting a number less than or equal. This is a 4. Less than or equal. In previous sum, what? More than 4. In previous sum, more than 4. Now, in this sum, less than or equal to 4. So, the favorable outcomes. Here, favorable outcomes are how many, children? Yes, 4. Favorable outcomes are 4. So, number of F is here 4. And here probability. Here probability. So, Once again, we recall the definition of probability. What is the definition of probability? Probability of an event is equal number of favorable outcomes divided by all possible outcomes. Here, probability of F. F means here what? Getting a number less than or equal to 4. Probability of getting a number less than or equal to 4. Simply we may take P of F. Simply we may take P of S is equal to favorable outcomes. Here what? 4. Here 4 means favorable outcomes. So by favorable outcomes which is divided by all possible outcomes. Total number of outcomes. Possible outcomes. And how many possible outcomes here? 6. Here 6. So 4 by 6. 4 by 6. In previous problem already 1 by 3 probability. Here 4 by 6. 4 by 6, 2 2s are 4, 2 3s are 6. So 2 by 3 is the probability. So 2 by 3 is the probability. In the 1 by 3 is the probability. Here 2 by 3 is the probability. Now, so here we should try to learn elementary event. Write down, children. Elementary event. Elementary event. What is a elementary event? So here, an event having only one outcome in an experiment is called an elementary event. So children here have understood this. Elementary event means if we toss a coin, getting a head, favorable how many? 1. So, and also if we roll the die, getting a number 3, the favorable outcomes are how many? 1. So in the same way, an event having only one outcome, in an experiment is called an elementary event. So here means number of favorable outcomes must be 1. That's all. If the number of favorable outcomes 1, that event is called elementary event. So here in an experiment, the sum of the probabilities of all the elementary events is 1. Okay, here another is there. So note down this point, children. In an experiment, the sum of the probabilities of all elementary events. For example, I will try to give this information. But if we toss a coin about this, getting a head is probability is what? 1 by 2. Getting a tail probability is what? 1 by 2. So 1 by 2 plus 1 by 2 equal to 1, like that. And another example, if we take a die, when we roll the die, getting a number is on the top, getting a number 1, what is the probability? Yes, getting a number 1. What is the probability? 1 by 6. Okay. And getting two number. What is the probability? Yes, that is also 1 by 6. Favorable one, total 6. Getting 3, 1 by 6. Getting 4, 1 by 6. Getting 5, 1 by 6. Getting 6, 1 by 6 also. So we add these 6. 1 by 6 plus 1 by 6 plus 1 by 6 plus 1 by 6. 6 by 6. Here 6 by 6 is 1. So that means here. In an experiment, the sum of the probabilities of all the elementary events is 1. Okay, children, next here and we will discuss complementary events and probability. Children, listen carefully. This is also very important word, complementary events and probability. In previous session, we read about elementary events. Elementary events is nothing but total favorable outcomes only 1. Okay, rewind it. In the example 3, we calculated probability of events which are not elementary. We saw here. Why? Because here P of E plus P of F in this example 3, we get example 3, we get P of E is equal to 1 by 3 already with the probability of 4 greater than 4. Probability of getting greater than 4, 5, 6, so 1 by 3. And P of F, probability of getting less than 4 or equal to 4, 2 by 3. So these two, we add these two, So 1 by 3 plus 2 by 3. Here 3, 3. Here same, so we take 3 by 3, 1 plus 2, 3 by 3, like that. So here 1 plus 2, 3 by 3 is 1. So here F is the same as not E because there are only 2 events. In such case, only 2 events are there. 2 events are there. Here, if P of E plus P of F, F is the same as not E. This is not E. So these are because there are only 2 events are there. Next, and so here we denote the event not E by E bar. Not E by not E. We read as here a line is there on the top of E. So not E. We read as not E or E bar. This is called the complement event of event E. E bar is the complement event of E. We also denote like this E bar, not E. We read as not E. We write down like this bar here on the top, E bar. So here a formula is derived from that information is so P of E plus P of not E is equal to 1. P of E plus P of not E is equal to 1. And we may also written as P of E plus P of not E is equal to 1. This is the formula. This is complement to another complementary events, which is complementary events. Why? Complementary events means if 2 events, the sum of 2 events equal to 1. So they are each one is complementary event to each other. The complement to each other. So P of E plus P of not E is equal to 1, which gives us so we may take P of E this side. So P of not E is equal to 1 minus P of E. Write down this formula, children. P of E plus P of not E is equal to 1. P of E plus P of not E is equal to 1. So these two are complementary events, which gives us so here P of not E is equal to, so we take this that side 1 minus P of E. In general, it is true that for an event E. So P of not E is equal to 1 minus P of E. So this is the formula. From using this formula, we derive this one also. P of E is equal to 1 minus P of E. P of not E is equal to 1 minus P of E. So this is the main formula. P of E plus P of not E is equal to 1. Using this, P of not E is equal to 1 minus P of E. These are complement to one another. Once again. So complement of an event. Complement of event. See children here. The complement of an event E, with respect to sample space S is the set of all elements of S which are not in E. So this is more information about complement of an event. The complement of an event E with respect to sample space S, is the set of all elements of S, which are not in E. That is the complement. That is the complement and event. Now, so here this is already we discussed. P of E plus P of not E is equal to 1. Already we discussed. P of E plus P of not E is equal to 1. Here a sample space. The complement of an event E with respect to sample space is the set of all elements of S which are not in E, which are not in E. P of not in E. Okay, here P of E plus P of not E is equal to 1. This is a complement of an event. Write down this definition, children. So here this is very important to note. P of E plus P of not E is equal to what here? 1. P of E plus P of not is equal to 1. Next, children, once again. And another one is there, impossible and certain events. So we may discuss impossible and certain events. So children, here, see children, consider the following about the throws of a dice with sides marked as 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Number 1 here. What is the probability of getting a number 7 in a single throw of a dice? Listen carefully, children. A die, when we roll the die, here we find what is the probability of getting a number 7 in a single throw of a dice. When we roll a die, getting a number 7, the probability of getting a number 7. Think, children, what is the probability of getting a number 7 on the top of the die? So we know that there are only 6 possible outcomes in a single throw of this die. Okay, children, here only total how many possible? Only 6. But here we get 7. How it is possible? Is it possible? So we can. So here we know that there are only 6 possible outcomes in a single throw of this die. These outcomes are, what are outcomes? Sample space already we learned. So outcomes are 1, 2, 3, 4, 5, and 6. Since no face of the die is marked 7, have understood, children? There is no 7. There is no. The number 7 is no on the mark of the top. Only 6 numbers are there. Only 6 numbers are there. There is no 7. There is no outcome favorable to E7. So here there is no outcome favorable to 7. Why? Because only possibles are only 1, 2, 3, 4, 5, 6 only. There is no 7 number. That's why. That is the number of such outcomes is 0. Favorable outcomes is what here? 0. None. No. In other words, getting 7 in a single throw of a die is impossible. Is it possible to getting a 7 on the top of the die? No, it is not possible. Why? Because only 6 numbers are there. How can we get 7? So it is not possible. It is impossible. It is impossible. That's why. So P of getting a 7 is equal to number of favorable outcomes by all possible outcomes. All possible outcomes. So 0 by 6. 0 by 6 means 0. So when the probability is 0, that is the impossible event. When probability is 0, that is impossible event. Okay. So that is the probability of an event which is impossible to occur is 0. Such an event is called impossible event. So in some cases we get the probability is 0. That event is impossible event. Think, children. Another something how we get impossible. So there are so many new problems. Think, children. Okay. Now here, what is the probability of getting 6 or a number less than 6 in a single throw of a die? Another one is there. Here, getting a number 7 already we find. So here, second one is, what is the probability of getting 6 or a number less than 6? Getting 6, number less than 6, like that. So in a single throw of a dice, when we roll the die, the probability of getting 6 or less than 6. 6 are less than 6. So here, see children here, since every face of a die is marked with 6 or a number less than 6. So here, once again we recall the die. Die, every face 1, 2, it marked 1, 2, 3, 4, 5, 6. So every face of die marked with 6 or less than 6 only. Less than 6 only. It is sure that we will always get one of these when the dice is thrown once. So the number of favorable outcomes is the same as the number of all positive outcomes, which is 6. Here, the getting 6 or less than 6. If the sample space is what? 1, 2, 3, 4, 5, 6. Here we find the getting 6 or less than 6. How many favorable? Think. How many favorable? 6 favorable. How many favorable? 6 favorable. So favorable outcome 6, possible outcome 6. In previous case, there is no favorable outcomes, 0. Here, all possible outcomes equal to favorable outcomes. All possible outcomes equal to favorable outcomes. So 6 by 6. 6 by 6 means 1. So here the probability, when we get the probability is 1, when we get the probability is 1, such event is called sure event or certain event. Write down children. When we get probability 0, that is impossible event. When we get the probability 1 is a sure event or certain event. Write down this one. So the probability of a event which is sure must be 1. It should be sure or certain to occur is 1. Such an event is called sure event. Such an event is called sure event or certain event. Certain event. So, and from the definition of probability P of E, we see that the numerator, the number of outcomes favorable to event E, numerator, is always less than or equal to denominator. See children, once again we recall the formula of the probability. What is the formula probability? P of E is equal. P of E is equal to favorable outcomes divided with all possible outcomes. So in denominator must here denominator. Here the numerator is always less than numerator. Numerator always less than or equal to denominator. In any case, in probability only. In probability, when we find the probability, denominator here, numerator is always less than or equal to denominator. So that's why here probability, the probability always lies between 0 or equal to 0 less than or equal to P of E less than or equal to 1. Okay, here the probability must between 0 and 1, whether it be 0, it equal to 0 or equal to 1. Okay, it's a very important children. Here the probability is 0 less than or equal to P of E less than or equal to 1. So probability must be between 0 and 1, or when it is equal to 0, the probability is 0. That is a impossible event. And the probability is 1. So the probability should always between 0 and 1, or where it is equal to 0 or equal to 1. So we can write like this: 0 less than or equal to P of E less than or equal to 1. Okay, this is a very important. Note down children this: 0 less than or equal to P of E less than or equal to 1. So children, here some problems are there. So we discuss about it. So here, see children here, why is tossing a coin considered to be fair way of deciding which team should get the ball at the beginning of any game? When we toss it, in every game, we toss a coin, we toss a coin. Why? Give the answer, children. Why? Because, okay, right. Think about it. Why? Because it's a fair and unbiased equally chances. That's why we may take a coin in every beginning of any game. Beginning of any game. Okay, right. And we discuss with your friends also and your class teacher also. Children, okay. Now, second one. Can 7 by 2 be the probability of an event? Explain. Oh, here, children. 7 by 2 is the probability. Already we discussed just now. What probability is between 0 and 1 equal to 0 or 0 is less than or equal to probability less than or equal to 1. So here 7 by 2 means equal to 3.5. So it is not possible. It is not possible. Numerator is greater than denominator. Yes, 7 is greater than 2. That's why it's not explained. So please write down in your notes with explanation, children. Next, which of the following arguments are correct and which are not correct? Give reasons. If two coins are tossed simultaneously, there are three possible outcomes: two heads, two tails, or one of each. Therefore, for each of these outcomes, the probability is 1 by 3. Is it true? If two coins are tossed, children, how many possible outcomes? Try. How many possible outcomes? Is it true? Okay, children, discuss with your friends. Children, is it true or not? Okay. And one, if a die is thrown, there are two possible outcomes: an odd number or an even number. Therefore, the probability of getting an odd number is 1 by 2. So, children, think, children, and discuss with your friends. Is it true or not? Try to learn about these, children. Okay, we can discuss. And one. Okay, children. Now, so I will try to give some information about deck of cards, children. So tomorrow our topic is totally based on the probability of deck of cards. Probability of deck of cards, children. So children, here, have you seen a deck of playing cards, children? Do you know about playing cards? Okay, right. A deck of playing cards consists of 52 cards. How many cards? Deck of cards? 52 cards, which are divided into 4 suits of 13 cards each. They are black spade. So this is shape black spade. So children, red heart, red diamond, and black clubs. So these are 4 suits. 1, 2, 3, 4. 4 suits are there. How many suits are there? 4 suits are there. That's why in every suit 13 cards are there. So 13 into 4, 13, 4, 50. Total how many deck of cards? 52. So we must understand about these deck of cards. So children, tomorrow you must gather more information on deck of cards. Deck of cards, like how many cards and shapes, how many cards, shapes, how many suits. So, and also you must try to identify shapes. Here 4 shapes are there. Once again, you see about deck of cards, children. And also tomorrow you must gain some knowledge about the deck of cards. It is very easy to solve the problems. Tomorrow. So you must gain some knowledge. Discuss with your friends. So ask about playing cards. How many cards are there? What are the shapes? How many suits? And how many each should contain how many cards? So totally you must gain some knowledge tomorrow. Then we start next class using your knowledge. Okay, children. Thank you.
Thank you very much, sir. Purushottam sir.
Sir.
So Purushottam sir has discussed about the probability basic concepts. So what is probability? What is an favorable outcome, and the ratio of the total sample points to the favorable outcome is nothing but the probability, and the various types of questions based on the probability. That is, one is based on the tossing of a coin, and another one is uh, rolling a die, and what is a certain event when you will get the probability as 1, and what is an complementary of the probability of probability of E bar is also is given to you. And one more important concept, that is problems based on a deck of cards. The types of cards in a deck based on color and based on their symbols, which is already given a little bit of basic concept to you, which is possible. If it is possible to you go through the cards and what are the how many colored cards are there in the deck, and excluding the joker cards, so total 52 cards, you can verify that one. So if it is possible to you, you go through the types of colors. One is black, another one is red, and next one is what are the types of cards which symbols, with symbols it is given to you there. That is hearts, diamond, flower, and spades is also given to you with the symbols by our Purushottam sir. Each deck, each color has a 13 cards, and the total black has 26 and the red has 26. All together is 52 cards. You, once if possible, you go through the all cards and separate them into category wise, and what are the numbers you will get, and take the classification of that one. That will be more useful for you while you are solving the deck of card questions based on that one on Monday. So these 3 days, tomorrow, day after tomorrow, and Sunday, these 3 days are holidays, and we will see you on Monday at same time 9 o'clock. Thank you, Purushottam sir. Thank you for the technical team who supported for the online live streaming classes. Thank you, sir. Thank you, Srinivas sir.
Thank you.
Thank you, Gurumut sir.